Why is math so hard? If you feel this way, you're not alone.
In fact, more than half of the world's population struggles to utilize math when solving multi-step problems, according to data collected by the Program for the International Assessment of Adult Competencies. In 2011, the PIAAC first distributed a standardized test to 25 countries worldwide, which categorized test takers ranging from 16 to 65-year-olds into what they call proficiency levels. These 6 proficiency levels range from below level 1, categorized by tasks like performing basic arithmetic operations or recognizing common spatial representations, all the way up through level 5, which require the respondent to understand complex representations and abstract and formal mathematical and statistical ideas.
Only 1% of participants were classified as level 5. But a whopping 56% of them were unable to solve this level 3 question.
Many, if not all of us, have encountered sales like this in our real lives, so this question tests a useful and practical set of mathematical skills. Since the test denied the use of electronic aids, it's possible the challenges on this problem were mostly due to faulty arithmetic.
If the majority of adults don't understand if they can collect on a shoe sale, how can we expect students to understand this?
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Sorry, I was just getting really into it. No, you're right, we should stay focused. Maybe a more important question is, why do students and adults alike struggle with mathematical concepts? Mathematics education is the study of learning, teaching, and researching how mathematical knowledge is transferred to students. Researchers in math education widely believe that struggles in mathematics stem from 2 main factors that are ingrained in students from a very young age. These are societal beliefs and failures in the education system. Societal beliefs have a major impact on childhood development.
A 2018 study showed that out of over 1,000 US students surveyed, 75% of them heard adults or even their own parents speak negatively about math. Perceived negativity from adults and role models can shape the beliefs of students to also dislike the subject, and this propagation of disdain for mathematics from parents to children is concerning. Despite this, almost half of the participants said they actually enjoyed math, while less than a quarter said they hated it.
This shows a positive outlook for the future, which may over time shift society's view on the subject. The education system is also to blame for students falling behind and disliking mathematics. Unlike other subjects, advanced courses in math rely heavily on the material covered in earlier years.
Calculus requires a mastery of trigonometry and algebra, which in turn pull concepts from geometry and fractions, and these subjects build upon fundamentals in logical reasoning and arithmetic. If just one piece of this ever-growing tower isn't solidified before moving on to the next subject, the tower will collapse and the student will fail.
This places a great burden on early teachers and educators to build up strong fundamentals in math from an early age. Otherwise, the students won't be able to grasp more advanced concepts. Unfortunately, most primary school teachers don't have a background in mathematics. As such, they force students to memorize formulas rather than derive the concepts from basic principles.
Do you remember learning the Pythagorean theorem for the first time? If so, were you taught the formula with no explanation? Or did you see a beautiful proof like this to accompany it? Memorizing formulas may lead to the most success in the short term when you need to cram before a test, but it fails to prepare students for the long-term challenges of real-world problem solving and advanced math courses where the solutions aren't always so cut and dry.
I should mention that there are several learning and psychological disorders that can affect math comprehension.
Dyscalculia, dyslexia, and math anxiety all make learning math difficult for students and adults alike. And almost a quarter of the population has one of these disorders. The good news is some of them are curable, and those that aren't can be treated to reduce the negative effects.
So, what is the best way to teach math? In 1969, Dutch mathematician Hans Freudenthal established the International Congress for Mathematical Education to explore this very issue. He had a revolutionary idea that math was best learned by mathematizing the world around students using real situations. Rather than shove endless formulas and worksheets in their faces and forcing them to memorize a solution process, Freudenthal advocated for taking practical, real-world examples and presenting these as the tools to build a fundamental interest that will pique students' interest in the subject of mathematics and help them learn creative mathematical problem-solving tools. This approach, known as realistic mathematics education, has gained a bit of traction since its inception and is still actually widely advocated for to this day. In fact, Freudenthal's home country of the Netherlands performed quite well in the recent PIAAC studies, with 57% of participants scoring at level 3 or higher. This begs the question, why don't education systems worldwide adopt RME? Don't look at me. I don't have all the answers. But fear not. If you've made it this far into the video, there's good news. There's something you can do, whether you're a student or experienced professional, to learn critical thinking math skills that will aid you in problem solving in a wide array of disciplines throughout many aspects of life. And that thing is math contests. But wait, don't you have to be good at math to do math contests? Actually, no.
Allow me to introduce Po-Shen Lo, head coach of the USA team for the International Math Olympiad from 2014 to 2023, placing first 4 times. Lo, along with many other math educators, believe exposing students to contest math problems aids their development of critical thinking and reasoning skills across a wide array of subjects. Unlike problems from school classes, math contests strive to introduce new puzzles that students haven't encountered before and ask them to think outside the box to solve problems. Merely memorizing formulas won't help students succeed here. Instead, they have to take an unfamiliar problem and find a solution plan from scratch using tools they understand. This type of analytical process can easily be extrapolated to other school subjects and to the real-world projects you encounter in your professional lives.
The best part of contest math is that there are a wide range of competitions readily available for enthusiasts or casual learners to explore.
In the United States, these range from the Noetic Learning Math Contest, starting with 2nd grade, through to the Putnam Competition for college students. If you're not a US resident, there are plenty of competitions all over the globe.
I'll leave links to some information and recent contests in the description of the video if you want to check them out yourself. Before I wrap up this video, I want to show an example of a contest math problem that you can use to stump your friends, and I'll show you an example of a clever outside-the-box solution method.
Suppose you're organizing a tennis tournament with 117 players. The tournament takes place in rounds, where if there are an odd number of players left, one of the players receives a bye, and the remaining players are paired off in single elimination games. You want to know how many rounds it will take before you have a winner, and how many matches will be played in total. After seeing this problem, and releasing an audible groan, many would resort to building a table and counting out the rounds and matches as seen here. While this method is effective in this instance, and will get you to the solution of 7 rounds and 116 total matches, it can be rife with errors in arithmetic. Maybe more importantly, this solution method isn't easily generalizable for similar problems. Instead, there's an alternative solution which bypasses this tedious bookkeeping. First, let's turn to the question of the number of matches. Since a single loss eliminates a player, and there is only one winner at the end, this means by the end of the tournament there is one player with no losses, and 116 players, each with exactly one loss. So, that means we play 116 matches. Now to think about the number of rounds. Every round eliminates half of the remaining players rounded down. So the first round we go from 117 to 117 over 2. Then we go from 117 over 2 to 117 over 2 over 2, which is 117 over 4. Do you see the pattern? Every round we divide by 2 and then round up to the nearest whole number to get the remaining number of players. So after 4 rounds, we would have 117 over 2 to the 4th players remaining. Now that the pattern is merged, we can find the lowest power of 2, which makes this equation equal to 1. That would be 7, since 2 to the 7th is 128. So there will be 7 rounds in total.